Good afternoon. Whoa. I don't usually have that good of a speaker. My name is Gina Cinta, and I'm with Talis Trusted Cyber Technologies. I'm the Deputy CTO. Today we're going to talk about data protection at the edge. Who is Talis Trusted Cyber Technologies? We are a sole U.S. provider of cybersecurity solutions to the U.S. federal government. We're a very small business under a very large Talis umbrella that's a global company. There are over 40,000 employees. We're 100 on a good day. But we strictly sell to the U.S. federal government. Our solutions to help protect your data at rest and in motion and provide identity access management solutions. So I like to start out this presentation by asking, and don't answer, but think about it. I'd like to hear your answers afterwards. What does edge mean to you? Because I get different answers all the time, and it helps me understand and kind of hone the conversation. But really, what does the edge mean to you? It could be one gentleman had a company that sells like video cameras, surveillance video cameras, and that's his edge where he needs to protect that video feed going back to the enterprise, right? One lady told me that getting into the Doden network feels like being on the edge to her, where somebody from Doden found that very surprising, but I wasn't going to get in the middle of that conversation either. You could be a field hospital. It could be, like, think of like a situation where there's like a hurricane and a disaster, and now FEMA's got to deploy. That becomes their edge, right? Because they've got to stand up a field operation and be able to protect that data, about those individuals that they're helping through that disaster. And then also think about, from a data protection perspective, there's all different types of data, and how do you go about protecting that? It could be transferring data to and from a data center to a branch office or to the cloud. It could be voice and video operations. It could be transporting large amounts of data to a disaster recovery site or a data center or some branch office or remote site. So, and there's all different types of data. There's databases, there's unstructured data, and all of those have requirements for being protected in a different way. One of the terminologies I heard this morning was sensitive but unclassified encrypted. That's right what we're talking about today, right? Where you can encrypt that data at rest and in motion to be able to share it with your coalition partners and with other organizations. So when we talk about common edge deployments, it could be a small storage deployment. It might be a branch or remote office, maybe a disaster recovery site, which nowadays sometimes disaster recovery is in the cloud. It's not in another data center. It's using a cloud data center. Or a remote lights out non-manageable facility, or a lab or a proof of concept deployment. And then there's tactical deployments where you're out at the forward edge. You're also operating small bases in another location. So there's a lot of different types of deployments that are considered edge. And when you're talking about edge and securing that, and what are the challenges associated with that? Well, there's environmental challenges as well as operational challenges. And from an environment perspective, you could be talking about harsh environmental conditions. Like, think about Iraq and Iran, where you have like a lot of sand and dust and dirt. Or you could be at sea and you have to think about, salt water. So those are different examples of harsh conditions. Then you also have to look at SWAP, size, weight, and power constraints. So like, what is the size of my facility that can handle, the storage that I need and the compute that I need and the, maybe virtualization and security and networking. So those are all things you have to take into consideration. And loss of equipment control. What if for some reason there's a hostile situation and you have to leave immediately and you can't take the equipment with you? Is there a way that it's secured that when you leave, should your adversary be able to apprehend your equipment, they don't have access to that sensitive information? And then bandwidth limitations. Maybe in your headquarters data center, you're operating at a 10 gig or 1 gig line speed, but out in the field you might be running at 10 meg, and now you've got to think about what's the uptime for loading data to and from my edge to the cloud or to the core, depending on the line speeds you're operating with out at the edge versus at the enterprise level. From an operational perspective, there are training difficulties, and some of the conversations I heard earlier today in the sessions are very training focused, and especially when you're out at the edge, you don't always have your subject matter experts there to do the really hard work of managing an environment. So it has to be easy to manage and easy to use, because you're not necessarily going to have the same type of support you have when you're sitting at the enterprise or headquarters environment. And then the equipment has to be able to do things that might require you to meet compliance, like zero trust or some kind of compliance mandate where it does auditing and logging so it can keep track of what is the activity that's happening associated with this data that's being protected. And then how do I transfer that data, whether I'm at the edge and I need to transfer it back up to the core cloud or enterprise level, or how do I transfer it back down? Because the storage constraints I might have at the edge are not nearly what you have, the storage capabilities you have, in your primary data center in the cloud. And you need to make sure you have just the right data, and then anything you create or modify or update has to then be uploaded to the enterprise so it can stay in sync with what you're doing out at the edge. So these are all considerations and challenges with securing that data at the edge. So let's take a look at how can we extend that data protection at the edge. First of all, you want to be able to encrypt edge-generated data, because if you're at the edge and you're in a hostile environment, you don't want your adversary to get to that information that you're using or collecting, because it's more than likely very sensitive to classified information. And so how do you protect and encrypt that information and put strong access control, like who and what has access? Maybe I'm sitting at one computer and I have access to certain types of information, but my coworker sitting at another computer and across the room might not have the same access that I do. And how do you put that control around who and what has access to the information? And then protecting those keys. Anytime you talk, people talk so much about encryption, but they don't talk about the keys that are associated with encryption. And when you encrypt a piece of data, there's a key that's associated with that encryption. And that key is just as valuable, if not more so, than the encrypted data. Because if they can get the encryption key and the encrypted data, they can access that information. It's just like the key to your house. As long as you have the key and you lock the door and you leave, your house and your belongings are protected. But if you leave that key like under the doormat, as we say, then anybody could find that key, get into your house, and then have access to your protected information. That's the same concept with encryption. And when you generate these encryption keys, you have to think about the life cycle of the key as well. I generate a key today. I don't necessarily want that key to be used indefinitely. Maybe I have a policy within my organization to rotate that key every 90 days or annually. So you have to have a solution that can support that key rotation and life cycle of the key. Maybe for some reason you need to destroy or deactivate a key. You have to have that key manager capability in order to manage that entire life cycle. Creation, rotation, archival, and destruction. And oftentimes there's encryption solutions on the market that do onboard key management, but don't really offer the capabilities of a full lifecycle key management solution, and you're beholden to them to manage those keys. Like a cloud provider that encrypts your data, because you go, oh, I want this encrypted, so I'll check the box for the cloud provider to encrypt it. But you don't have any control over that key, the cloud provider does. What if you could generate a key in your own key manager, push it to the cloud? Now you're controlling that life cycle of the key, which is very important in any encryption solution. And then the access control, like using your CAC card or your SIPR card or some token to authenticate into the environment to say, I am a valid user of this application or of this environment. And maybe what I can access when I'm out deployed to the edge is different than what I can access when I'm sitting at the enterprise level. And then to be able to share that mission critical data, to be able to upload and download that and secure that data in transit, right? So you think about encrypting the data at the data center or at the edge, that's at rest. But when you're talking about transmitting the data to and from the cloud, from the enterprise to the edge to the core, that all needs to be encrypted too, because that's just as susceptible to being stolen as the data when it's sitting at rest in the data center. And sometimes an adversary finds that easier to steal than the data when it's inside your perimeter. So let's take a look at like right sizing the protection for the edge. On this side, these are the different ways you can encrypt and protect the data depending on where the data is. And then over here are examples of the different use cases that you might have. Excuse me. So you could want to encrypt your databases. Now, all database vendors have transparent database encryption. Where do they put their encryption keys? On the database server where the encrypted data is. So that's that same key under the doormat scenario. If you take that key at that root of trust and place it in a key manager external to that, now you've created a stronger security posture around your encryption and key management solution. And that root of trust could be through a hardware security module that's either embedded in a key manager or a hardware security module that is separate of the device as well. And then authentication, you all have a CAC card or a PIV card. You may have a SIPR card where you authenticate into different systems and environments. That plays a big part in the data protection solution. And if you think about zero trust, that's the first pillar you see in the zero trust architecture is identity management. And then that network encryption where you're securing that communication that's going out over the wire. Doesn't matter, that case, you don't care what the data is. Voice, video, large streams of data going to a data center or a disaster recovery site. It's encrypting everything before it goes out of the environment, decrypting it on the receiving end. So when you start talking about encrypting your data, you got to think about where is your data, okay? And in this example, the level of effort to deploy an encryption solution is directly related to the level of security that you want around that protected data. So at the very simplest level, you can do encryption at the storage level. Now, just about every storage vendor on the market has a self-encrypting drive solution or a software encryption solution to encrypt storage. And that is data at rest. Now, when the storage is powered on, is it at rest? No, it's in use. So that means it's really only a data protection solution when you power off your storage. How often is storage powered off? Not very often. If you're transporting it, now think about you're deploying a solution to the edge and you've got it in, like a flyaway kit or something. That is storage encryption is great for that because it's handling the protection of that data when it's being physically moved from one location to another. Other than an edge scenario from a data center to data center solution, I've had one customer in my 14 years with the company that actually was moving storage from one data center to another and needed a storage encryption solution. But it's a good first step, but doesn't give you that granular access control that you need. You can do encryption at the virtual machine level, and that's because that's a software-based solution, and that's easily stolen. Then at the file level, unstructured data, think about your PDF files, your Word documents, your Excel spreadsheets, all that's unstructured data, and that can be encrypted with access control around it. And then, like I talked about, the databases and the vendors that provide that solution. But then there's also doing encryption at the application layer. Highest level of data protection because you're putting the encryption into the application. So no matter where that data ends up, whether it's a database, a file, on a virtual machine in storage, on-premise in the cloud, it's all encrypted. Highest level protection takes a little bit more to deploy because you got to know your data better in order to put the policy around that encryption. So from a key management perspective and an edge solution, you may want to talk about using hardware, or you might want to use a virtual key manager. With the hardware solution, small form factor is going to be important at the edge. It needs to be lightweight and portable. And then you need to have security around it because that device, should you have to leave it behind, you need to make sure it's secure. So if you can have this capability called crypto erase, so you have a root of trust in your key manager, it's usually based on a token that's in your key manager device. When you remove that key, because you have to leave, you're in a hostile situation, You've now taken that root of trust with you. You've created a crypto erase scenario. You did not delete any of the material on the device. You've merely locked it down. So then, if you're able to go back to this environment to get access to your environment again, you put the token back in, and now you can boot it up and you have access. So that's a really powerful use case with that remote token. And then in a virtual, you can have a root of trust to a hardware security module, but it's a great use case. All the cloud providers, you can use a key manager in a virtual environment in the cloud and on your premise. And it handles the entire life cycle of the keys that you generate on that key manager. When you talk about use cases or different types of storage or data, there's data protection you can do transparently, where it's like file folder level. As long as you have access, you don't know you're encrypting and decrypting. If you don't have access, you know, because it will say access denied. Okay, so it's meant to be transparent to the user that's authorized. From a storage perspective, like I said, a lot of the storage vendors have software or self-encrypting drive solutions to encrypt the storage. You can do, a lot of the vendors do encryption on the server level. And then in virtual environments also offer these encryption solutions. A lot of them have onboard key management, but like I said, it's better to have that external key manager so you can manage the life cycle of those keys. And then you can't really talk about identity access management without talking about ICAM, because that's a big conversation around zero trust. But to be able to, as a customer, a user, a partner, authenticating into an environment, you have a variety of solutions. You can use a certificate-based authentication token or smart card. You could use a, a FIDO smart card or a FIDO PKI Fusion token, and then be able to authenticate to your applications, your data, your identities are stored and secured on a hardware security module. So it gives you a strong identity access management solution. Now, talking about encrypting the data in motion, remember I said it's all the data going out over the wire. It can operate at layer 2, layer 3, or layer 4. Layer 2 is the most optimum with low to no latency over the wire. It's kind of a set it and forget it. You put these encryptors at each point where you want the data to be encrypted before it goes out of the environment. And then when it's received on the other side, it decrypts it on the other end. And we can support, and there's solutions on the market, not only ours, that you can do point-to-point, point-to-multipoint, or a fully meshed architecture. You can do anything from 10 meg to 100 gig line speed, and they don't have to all be the same line speed across the network, which is good because you don't want to be limited and have to be forced into using the same line speed, which you may not have that option. Out at the edge, your line speeds tend to be a lot slower. So let's take a look at, I've talked about key management, I talked about encryption of data at rest, so let's take a look at the whole solution from the core to the cloud to the edge. So at the core or the cloud level on premise, you can encrypt the databases, you can do transparent encryption or that highest level data protection with application level encryption. You can then secure that with a centralized key manager with a root of trust in that hardware security module or that hardware security token if you're using a smaller device. That's a FIPS certified hardware appliance. Then controlling the access through identity access management, and then sharing that data out over the network through high-speed network encryption. And you can do that to a remote site where it's storing locally stored data that's protected at rest. It could be a smaller form factor or a virtual key manager at the remote site, could have a root of trust to an HSM, authenticating the users at the remote site. So this could potentially be disconnected from the enterprise, not necessarily, but you still can have that communication securely with network-based encryption from the data center, the cloud, to your remote site. And then out to the tactical edge, you have a smaller subset of that data, along with the smaller form factor key manager, could be virtual, with the root of trust to the HSM, so you can do that crypto erase, identity access management with the users to that remote environment, and then being on the network, being able to secure the data, whether you're sending to a remote site or you're sending it back to the core, or you're receiving information from the cloud, from the core, enterprise, remote site, or the tactical edge. And when you're disconnected at the tactical edge, you now have everything you need in one location. You have the key manager managing the keys that have encrypted the data, along with access management to control who and what has access to the information. Questions? We got no time left, but if you want to ask any questions or talk, any edge solutions that you can think of that we didn't talk about? What does it mean to you? Okay, I guess we touched everything. Thank you so much.